Establishing realistic kinematic definition of models with angled faces can be very challenging. The problem we have here is how to get the drill head to match the angle of the small red part. Let's see how NX solves this problem. We already have the basic kinematic definition solved. We have our ridge groups defined, so anything with color will move, and we also have the joints established, so that defines how those ridge groups can move. And we have some fixed joints, a slider joint, and a few cylindrical joints. To get an idea of what the movement could look like, we're going to use the move ridge group command and just move some things around to see what the general behavior is going to be like. And we see things rotate and they slide back and forth, except for the small drill bit, it's not moving around. Ideally, we'd like to put a screw joint on here so we can have some realistic behavior of this thing spinning and protruding in or out of the part at the same time. So some new capability allows us to do just that. We'll add a screw joint. Process is pretty simple. Just pick the first part, the second part, the axis of revolution, and the pitch. Here we'll just take the default of 10. Now that that's complete, we have all of our kinematic definition ready. Now we're ready to add motors. As I mentioned, the problem is how to add motors to get the angle of the cutter head to match the angle of the part. Inverse kinematics is something we've just added to NX and makes this process very simple. All we need to do is simply identify the first part and a key point on that part, and then we're going to go to the actual angled face here and pick the center point of that, and we're going to rotate the triad to match the angle of the cutter head that we want to have drilled into the part. One last thing I'm going to do is I'm going to add a little bit of offset to this so we can actually have the drill head stop and then the drill bit protrude into the actual part. That's all it takes to establish all of the motors. So if we look at our navigator, we can see we have several motors on here. And if I change the option color to motor color, we can see how we have all these motors added. A quick play shows how the kinematic behavior has been correctly established. Let's launch our timeline so we can see this in slower motion. As I move my cursor back and forth, notice how the cutter head is angled, it's rotated, the traveler moves back and forth, and gets the cutter in the right position for the drill. The next operation we'll add is a small motor to add the movement to the actual drill itself. So what we'll do is we'll add a position motor, and we'll simply pick the screw joint, and I'm going to change my option to let the system calculate the angle, because I don't know what that is, but I do know the end time and the speed. Then we'll key in 1000 for the speed. And if I hit play, notice how it protrudes that drill bit into the part. Let's turn our joints off for a second and turn our motor color off. And let's move our cursor back and forth. Now ideally I'd like the drill to be the last operation, so what we're going to do is simply move that event out. And to get everything to happen in reverse, I'm going to select all of these operations, and with a handy mirror operation we'll duplicate that in reverse order. Now we hit play. Notice how the drill head stops, the drill goes into the part and retracts back. Imagine doing this without inverse kinematics. NX makes life easy for you. Thanks for watching.